Namaskar, welcome to PKS classes. Today we will discuss normality, molarity and molality. We know in chemistry these are the units of concentration. We use these three terms: normality, molarity and molality. Normality is the number of equivalents of solute per liter of solution or gram equivalents of solute per liter of solution. Molarity is the number of moles of solute per liter of solution or gram moles of solute per liter of solution. Molality is the number of moles of solute per kg of solvent. So the difference here is in normality and molarity we use per liter of solution, whereas in molality we use per kg of the solvent. So 1 mole is 6.022 into 10 to the power 23 number of atoms or molecules of a substance. So when we say 1 mole means this number of 6.022 into 10 to the power 23 number of atoms or molecules will be 1 mole. So when we say molarity, molarity is the moles of solute for volume of solution in liters, volume of solution. So moles of solute is the mass of solute by molecular weight of the solute, because 1 gram mole is equal to molecular weight in grams. Suppose sodium chloride molecular weight is 58.5. So 58.5 gram sodium chloride if we take, then that will contain 6.022 into 10 to the power 23 number of sodium chloride molecules. So 58.5 gram sodium chloride is equal to 1 mole of sodium chloride. So we know that 1 molar, we usually represent it as the capital M. So 1 molar sodium chloride means 1 mole of sodium chloride per 1 liter of the solution. So that means 58.5 gram of sodium chloride per 1 liter of the solution will be 1 m NaCl solution. So let us take another example. What is the molarity of a solution if 117 gram sodium chloride is dissolved in water to make a solution of 1 liter? So we know the molarity formula is the moles of solute by volume of solution in liters, and so molarity M is equal to moles of solute, and that means moles of sodium chloride in 1 liter of solution, and it is 1 liter it is taken, so nothing to worry about this. So moles of sodium chloride, we know that 1 mole is equal to the sodium chloride molecular weight in grams, so that is 58.5 grams of sodium chloride. So when we say 117 gram, that means it will be 2 moles, and for that also we can use this formula: moles of solute is equal to mass of solute by molecular weight of the solute. So here moles of sodium chloride is equal to mass given here is in the question is 117 by 58.5 is the molecular weight, so 2 moles. So we have taken 2 moles for 1 liter of solution, so that means 2m. So if we dissolve 117 gram of sodium chloride in a solution of 1 liter, then it will be 2 molar solution. M here is molarity or molar, we can say it is 2 molar solution. Next, molality. In case of molality, we use the moles of solute per mass of solvent in kilogram. So here it is the weight taken in kilogram. So potassium chloride, suppose potassium chloride solution we are taking. So here the molality is represented as small m. Molarity is capital M and molality is small m, and molality is moles of solute or mass of solvent in kilogram. So 1 molal potassium chloride is 1 mole of potassium chloride by 1 kg of water. So 1 mole, as we said, the molecular weight 74.5 gram. So 74.5 gram of potassium chloride, if dissolved in 1 kg of water, then we will get 1 molal solution. That is molar in case of molarity, here molal in case of molality. So let us take one example. If 37.25 gram of potassium chloride is dissolved in 250 ml of water, then what is its molality? So water, we know water density of water is 1. So we know density is equal to mass by volume. So mass is equal to density into volume. So density is 1. So here it will be equal to V. So here 250 ml is taken. 250 ml means 250 is equal to 250 gram. And so density of water here means it is 1 gram per ml. So 250 ml of water is equal to 250 gram of water. Then potassium chloride, the molecular weight of potassium chloride is 74.5. So number of moles of potassium chloride here is 37.25 divided by 74.5. So it will be 1 by 2. So now, as per the formula, molality small m is equal to number of moles 1 by 2 by 250 gram, that is 250 by 1000 kg. So 1 by 4 kg. So 1 by 2 by 1 by 4 is equal to 1 by 2 into 4, 2 m or 2 molal solution. So in this way you can calculate the molality. Find the molality of a solution if 2 moles of solute is dissolved in 629 ml of carbon tetrachloride. So here it is given in volume, so we have to convert it into kg. So density we know, and we have just discussed that mass is equal to density into volume. So here mass is equal to density into volume, that is 629 into 1.59 is the density. So it is almost 1000 gram or 1 kg. And we have taken 2 moles. So molarity is number of moles is 2 for 1 kg of the solvent. So it is 2. So the molality of the solution is 2m. Answer. Now normality is the number of equivalents per liter of solution, and number of equivalents is the mass of solute by equivalent weight of the solute. And how you can calculate the equivalent weight? Equivalent weight is equal to molecular weight by the n factor or the valence factor. And n factor for acids, it is equal to the basicity or the number of hydrogen ions provided, and for bases the n factor is the acidity or the number of hydroxide ions provided. So suppose example, sulfuric acid H2SO4, so 2H it can provide. So molecular weight by basicity is equal to 98 by 2 is equal to 49. So equivalent weight is 49, molecular weight is 98. Similarly, for sodium hydroxide, equivalent weight is equal to molecular weight by acidity, and here 1 OH can provide. So acidity is 1. So 40 by 1 is 40. So molecular weight is equal to equivalent weight for sodium hydroxide. So in this case, we can say 1 normal sodium hydroxide is equal to 1 molar sodium hydroxide, because the molecular weight and the equivalent weight both are same. But in case of H2SO4, it will not be same. So let us do it. What is the relation between normality and molarity of H2SO4? So normality for H2SO4, is gram equivalents per liter. So suppose 1 normal H2SO4 we say, that means 49 gram of H2SO4 in 1 liter of solution. So this is normality, or we can say 1 normal is equal. Okay, and if we take 1 molar, then it will be molecular weight in grams. 1 mole is equivalent to, so 98 gram H2SO4 per 1 liter of solution. So we can write this one as 2 into 49 gram of H2SO4 per 1 liter of solution, and we know this one is 1 normal, so 2N. So we can say that 1 molar H2SO4 is equivalent to 2 normal H2SO4. So in this way we can correlate the normality and molarity. Again, we also use valence factor for calculating for salts. The valence factor as the number of electrons which is gained or lost per atom. So for example, sodium chloride, Na plus Cl minus, 1 electron sodium is losing and chloride is gaining. Similarly, potassium chloride, in calcium chloride, calcium is losing 2 electrons and 2 chloride atoms are gaining these electrons. So here, in case of sodium chloride, valence factor will be 1, potassium chloride valence factor will be 1, but in calcium chloride valence factor will be 2. So for equivalent weight calculation, molecular weight by the valence factor, so equivalent weight of sodium chloride will be equal to the molecular weight, equivalent weight of potassium chloride will be equal to the molecular weight, whereas equivalent weight of calcium chloride will be molecular weight divided by 2, and that is 110 by 2 is 55. So we can say that 1N sodium chloride is equal to 1M sodium chloride, 1N potassium chloride is equal to 1M potassium chloride. But for calcium chloride it will be different. So find the normality and molarity of calcium chloride solution if 220 gram of calcium chloride is dissolved in 500 ml of solution. So number of moles of calcium chloride is 220 gram we have taken, divided by molecular weight 110, so 2 moles. And number of equivalents of calcium chloride, and we have calculated that the equivalent weight is 55, so it will be 220 by 55, so it will be 4 equivalents. So per liter of, if we would have taken 1 liter of solution, then it would have 2 molar and 4 normal. And if here we have taken 500 ml of solution in this question. So is number of 500 ml is equal to 1 by 2 liter. So normality is equal to number of equivalents per liter of solution. So here number of equivalent is 4 and it is half liter, so it will be 8 normal. And for calculation of molarity, number of moles is 2 by half liter, so it will be 4 molar. So the solution given is 8 normal and 4 molar. So almost 1 molar is equal to 2 normal. So this is all about the normality, molarity and molality and their relation. Thank you.